Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering a question from one of the old papers from January 2005. This is the C1 paper, which came before the C1-2 papers and the P1, which is the new syllabus. But this is a question which is related to the P1 syllabus on integration, I guess, differentiation and integration. It says, this is question number 9 from that January 2005 paper. One of my students has asked me to answer this question, so I'm going to go through this. So the gradient of the curve C is given by dy dx equals 3x minus 1 squared. The point P, which is 1, 4, lies on C. Find an equation of the normal to C at P. So this is part A of the question. So we've got to find the equation of the normal to the curve C at P. Now what does that mean? Well, you have a curve. Okay, so we don't know what the curve looks like. You know, we're just gonna I'll just draw a bit of a curve. Okay, just zoomed in a bit of the curve. It says the point P 1, 4 lies on C. Just say this is a point P, and it says here that the equation of the normal to C at P is what we have to find. Okay, now what is the equation of a normal to a curve? Well, first we've got to understand what a tangent to a curve is. And a tangent to a curve is a line which just touches the curve at a point without actually cutting through it. So basically what happens is the tangent shares the same gradient of the curve at that point. And the normal is basically the line which is perpendicular to the tangent and goes through that same point. So this is the tangent and this is the normal. Okay, the tangent has the same gradient of the curve at the point where it touches the curve, and the normal goes through the same point where the tangent touches the curve but is at 90 degrees to it, perpendicular. So that's what the normal to a curve is. So if we understand that, we can then understand how to answer this question. So it says find the equation of the normal. The normal is a straight line. To find the equation of a straight line, we need two things. One of the things we need is the point that lies on the line, which we have, because the point P 1, 4 lies on that line. And the second thing that we need is we need the gradient of the line. So we need the gradient of the normal to the curve. So we need the gradient of this line. Now to find the gradient of the normal, we can use the gradient of the tangent, and we know that two gradients which are perpendicular, they will be negative reciprocals. Their product will be -1. So if I can find the gradient of the tangent, I can find the gradient of the normal. And I know that as the point P is where the tangent has the same gradient as the curve, I know that the gradient of the tangent is going to be given by given by the value of dy dx when x equals 1 at the point P. Okay, that's when x equals 1. So the gradient of the tangent will be equal to dy dx when x equals 1. So let's put x equals 1 into dy dx, and that will give us the gradient of the tangent, okay, at P. So dy dx is equal to 3 times, you got 3 times 3x minus 1. So let's put this in another bracket, 3 times 1 minus 1, and that's going to be squared. That's going to be 3 minus 1, 2, 2 squared, which is 4. So the gradient of the tangent is equal to 4. Therefore, the gradient of the normal is a negative reciprocal. So 4 is like 4 over 1. Turn it upside down and change its sign. So the gradient of the normal is equal to -1/4. So we can use that now to find the gradient of the normal. Well, sorry, the equation of the normal. So I have these two bits of information, and I can use a variety of methods. And it didn't tell me in which form they want the equation of the normal, so I can write it in whichever form I prefer. So I like to use the method y minus y1 equals m times x minus x1. And some people like to use a method where they use y equals mx plus c. Both methods are perfectly fine. In both methods you need a point and you need the gradient of the line you're trying to find the equation of. So I'm going to show you the first method here, where the point here, this is x1 and y1. So you have y minus y1, which is 4, equals m, which is a gradient, minus 1/4, times x minus the x coordinate, which is 1. Now I have two choices here. If I want to express my answer as ax plus bx plus c equals 0, where a, b, c are integers, which sometimes they do ask us to do, then what I would do at the next stage here, I would multiply both sides by 4, in which case I'm going to get 4y minus 16 equals, I'm left with a minus 1 here. When I multiply this side by 4, that's a minus x plus 1. Bringing everything to one side, I'll have x plus 4y minus 16 minus 1 minus 17 is equal to 0. So that's how I would personally express my answer, and I'd be done. But some people might want to go from here and express it in the form of y equals mx plus c, which would be no problem. You have y minus 4 equals, that's minus a quarter x plus a quarter, and then you have to add 4 to both sides, so y equals minus a quarter x plus, and I'm going to add a quarter and 4, so plus a quarter plus 4 is like 16 over 4 if you write it as a fraction, so that's y equals minus a quarter x plus 17 over 4. So that's another form you can write it in. Both of them are perfectly correct. Y equals mx plus c, and x plus ax plus bx plus by plus c equals 0. Alternatively as well, we could use another method to work out the equation of the line by using this formula, where we just basically replace the y with 4 and the m with minus a quarter and the x with 1, and we find what c is. So 4 equals minus a quarter plus c, so you have to add 4 to both sides, so you have 4 plus a quarter, so 4 plus 1 over 4, which is 16 over 4 plus 1 over 4, which is 17 over 4. So c is equal to 17 over 4. So we're left with y equals minus a quarter x plus 17 over 4, which is the same answer that we got down here. And then if you wanted to express it in this form, we could multiply everything by 4. So you get 4y minus x plus 17. And then you could again bring everything on one side, x plus 4y minus 17 equals 0. So whichever way you prefer, you get the same two answers, whether you want to use this method to come to your answer or this method to come to your answer, whether you want to express your answer in terms of ax plus by plus c equals 0 or y equals mx plus c. All of those choices here are available to you because they didn't state in which form they want the equation to be written. So all of those forms are perfectly correct. These two methods and these two forms, however you wish to write your answer. So there's the answer to part A. Now for part B, it says find an equation for the curve C in the form y equals fx. So what we have here, we have dy dx, which is the gradient function. Now we want to find what y is. So what we got to do is we got to integrate. Y is going to be the integral of dy dx with respect to x. Okay, so we got to find what y is by integrating this gradient function to give us the original function. Now, in order to integrate this, we have to prepare it for integration. So what we're going to do here, well, in P1, in P3, we'll learn some other ways of dealing with integration as well. But in this case, what we're going to deal with it by expanding this bracket. So when you expand the bracket, you square the first term, 9x squared. You multiply these together and double it, so that's minus 6x. And you square the last term, and that gives you plus 1. That's expanded. Now we have separate terms which we can now integrate. So when we integrate, we remember we're going to get here, add 1 to the power, so it's 9x cubed over 3. So add 1 to the power, divide by the new power. Minus, add 1 to the power, 6x squared over 2. Plus, if you have a constant term, you just becomes an x. Okay, you just add an x to it. Just like, 1 times 1 becomes 1x. If it was 3, it becomes 3x. Just the reason being, when you differentiate x, you get 1, so integration is the reverse. And don't forget that you must put plus c, which stands for the constant that could have been cancelled out when you differentiated. A constant becomes 0, so you have to put c here when you integrate. All right, that c stands for the constant that could have been there if you differentiated. So now we have the equation of the curve. We haven't quite simplified it. Let's simplify a bit more first. You have y equals 3x cubed minus 3x squared plus x plus c. Now we have a further piece of information here that the point P, which has got the coordinates 1, 4, lies on the curve C. So we know that this point lies on this curve. So this point satisfies the equation of the curve, so we can use this point to find the value of C, because we know that when I put x equals 1 in here, y is going to equal 4, because that's what this point, if it lies on the curve, it will make the equation true. So when you put x equals 1 inside this equation, you have 3 times 1 cubed minus 3 times 1 squared plus 1 plus c, then 4 should come out as your result. That helps us to find c now. You say 4 equals 3 minus 3 plus 1 plus c. So this gives you 0. So 4 minus 1 equals c. So c is equal to 3. So now we can write down the equation. Y equals 3x cubed minus 3x squared plus x plus 3. And there is the equation of our curve, y in terms of y. So we've got the form y equals some function of x. So there we have the answer. 3x cubed minus 3x squared plus x plus 3. And that's the answer to part B. And now for part C, it says using dy dx equals 3x minus 1 all squared, show that there is no point on the curve C at which the tangent is parallel to the line y equals 1 minus 2x. Okay, so the curve, its gradient function is dy dx. So we can say that the gradient function of the curve is dy dx, which is equal to 3x minus 1 squared. So this tells us the gradient of the function. Okay, and the gradient of the line y equals 1 minus 2x, okay, has a gradient of negative 2. The gradient of the line is equal to negative 2. Okay, y equals mx plus c. So basically what they're trying to say is that the curve C, all right, will never have a gradient. We have to show that this will never have a gradient of negative 2. This curve will never have the gradient of negative 2. So we can see that 3x minus 1 all squared, okay, this is something which in fact will never be negative. 3x minus 1 all squared is always greater than or equal to 0, okay, for all values of x. We can see that because it's something inside here, whatever is going to be in here, even if it's negative, it's going to be squared. So this expression will always be greater than or equal to x for all values of x. Okay, therefore, we can say 3x minus 1 squared, okay, can never equal negative 2. It's not equal to negative 2 for any value of x, for any value of x. There's no value of x which will make this true, okay? So therefore, we can see that, we can say that the curve C, okay, will never have a gradient that is negative, you can say, that is negative. Therefore, okay, it can never be parallel. It can never be parallel to y equals 1 minus 2x. Okay, so that's like a simple little 2-mark question here where you have to think a little bit. Okay, we could have maybe also tried to equate this to minus 2. So we could have done it algebraically by saying 3x minus 1 squared equals negative 2. Now, of course, if you try to solve this just by the fact that you take the square root of both sides, it will say, you'll see that you'll get no solution. If you try to find the square root of both sides, you have 3x minus 1 equals, and you're going to have plus or minus the square root of minus 2. Plus or minus the square root of negative 2. So that's undefined. Okay, so there's no solution. So that's another way. We could have even expanded it, made it a quadratic, bring everything to one side, and then shown that the discriminant is negative, therefore there's no solution to this. There's different ways of doing it. The easiest way is probably just what I mentioned here. Just showing the fact that something, when you square it, that whole expression can never be equal to 0, and never be less than 0. It's always going to be greater than or equal to 0. Okay, so there's always going to be greater than or equal to 0, so therefore it can never be negative. So that's a little explanation of part C of this question. Other questions from this particular paper, if I get round to answering them, will be in the playlist that will appear over here. So if I do ever answer any questions from this paper, you will find a playlist that appears over here with the other questions in it. Other questions that deal with differentiation, okay, from P1, this is now P1, will be found in the playlist over here. You can subscribe to my channel by clicking on this link, and the video here will show you how to use the channel to find useful, parts of the channel that you're looking for, so you can get to navigate quickly to what you need from my channel. Thank you for watching, and see you soon.